Section 6.1 Example 4, we have some teachers adjust test scores when a test is difficult. One teacher's formula for adjusting scores is A equals 10 times the square root of R, where A is the adjusted score and R is the raw score. If the raw scores on one test range from 36 to 90, what is the range of the adjusted scores? Note that the square root of 90 is about 9.487. So if we have lowest raw score of 36 and highest raw score of 90, we can plug these values into this equation to figure out the adjusted score range. Hopefully the square root of 36 is familiar to you. So square root of 36 should give you 6, and then we're just going to multiply that by 10 to get 60. Square root of 90 is not one that you would normally have memorized, which is why I have it up here in the note. So we're going to use 9.487 as an approximation for the square root of 90. Notice that once we use an approximation, we change the equal sign to our squiggly lines, which mean about or approximately. Now we just need to multiply by 10, which means we will move the decimal place over 1 point. When you move the decimal place over once, you get 94.87. So the adjusted highest score is about 95. The adjusted scores range from 60 to 95. The work for this problem is written out on the next slide with extra explanation for you and a reminder to use a calculator if you don't know the square root of 90, which I don't expect you to know. Now I would like you to try number 11. In many classes, a passing test grade is 70. Using the formula A equals 10 times the square root of R, what raw score would a student need to get a passing grade after her test score is adjusted?